This fourth set of lecture videos is going to cover force. The goals for this chapter are relate force and the law of inertia, apply the law of acceleration, apply the characteristics of friction, analyze forces in one dimension, distinguish among weight, mass, and gravity, and analyze how the law of action and reaction is used. First, let's talk about force and the law of inertia. Before we can go too far, let's talk about force. A force is any push or pull. A force that is applied to an object will either change the motion of that object or it will prevent the object from changing its motion. It is important to note that force is a vector, so it will have a magnitude and a direction. An applied force that is unbalanced will produce an acceleration in the direction the net force is applied. Force is measured in newtons after Sir Isaac Newton in the metric system and pounds in the English system. You may need to convert between systems, so it is helpful to have the conversion factor 4.45 newtons equals 1 pound. If we look at this picture of a car, we can see that there are all kinds of forces acting on it. We have the engine providing a driving force, which is the largest arrow we see. We see a weight force pointing down towards the ground. There's air resistance and friction, both pointing in the opposite direction of motion. There's also a reaction force acting up on the car. We will talk more about this reaction force in a later video. Now that we know a little more about force, let's talk about Newton's first law of motion. Newton's first law states a body that is in motion continues in motion with the same velocity or speed and direction, and a body at rest continues at rest unless an outside or unbalanced force acts upon it. In other words, if you are sliding on a frictionless surface similar to ice, you will keep sliding in a straight line and at the same speed unless an outside or unbalanced force acts on you. If there is any friction, this would be considered an outside or unbalanced force, and it will cause you to slow down. Similarly, if you are sitting on a chair, you won't suddenly start moving or fall off unless an outside force acts on you. If your friend would push you, this would be an outside force, which would probably cause you to move or fall off the chair. Inertia is the property of resisting a change in motion. For example, the inertia of an object is the property that causes the object to remain at rest if it is originally at rest, or to continue moving with a constant velocity if it is originally moving unless an unbalanced force acts on it. When I say an unbalanced force, I mean that there is some net force acting on the object, or the net force is anything but zero. As an example of the law of inertia, it is much easier to push a small car than it is to push a large truck. The small car has less inertia, which again is the property that causes an object to remain at rest if it is already at rest. The truck has a much greater inertia, so it is much harder to get the truck moving. Mass is the measure of the inertia of an object. The small car has a much smaller mass than the large truck. Mass is measured in kilograms in the metric system or slugs in the English system. The conversion between systems is that 1 kilogram equals 0.0658 slugs. Another example of inertia is a car on ice or snow. The inertia of the car causes the car to want to keep moving if you slam on the brakes, since the outside frictional force is very small as compared to a car trying to stop on pavement where the friction is much greater. This concludes our first video on Newton's first law of inertia.